Hi, everybody. I'm Josh Barrow. I'm actually columnist for Insider, and I'm host of KCRW's Left, Right, and Center. And we are here today to talk about artificial intelligence. The COVID pandemic has accelerated the adoption of digital technologies throughout the economy, first as a way to enable social distancing and remote work, and then as a way to adjust to strong consumer demand and a tight labor market. There's a strong desire in business to find ways for machines to do what humans used to do, and that obviously includes demand for artificial intelligence. And I'm here with a great panel today to talk about what those changes mean for entrepreneurs, for investors, for workers, and for consumers. Their biographies are on the conference website. I'm not going to go through them in detail, but I will briefly give their titles. Stephen Lau is Managing Director at WorldQuant Ventures. Sorry, I'm having trouble with my notes. Amar Hanspal is CEO and co-founder of Bright Machines. Amir Hussain is CEO and founder of Spark Cognition, and Sofia Elizondo is COO and co-founder of Brightseed. So actually, I want to start with Stephen, since you're on the investing side. What big changes have you seen over the last 2 years? How has the pandemic changed the way that you look at investing related to artificial intelligence?
So just starting at a very high level, during the pandemic, and post-pandemic, we saw a surge in capital that has flowed into many companies, into capital markets, into tech companies, big and small. And that influx of capital, and also driven by the demand around COVID, had really pushed technologies and things that have been happening for many years. It really accelerated the pace of change, across healthcare, across retail, CPG, across finance, pretty much across all areas of industry. But a total acceleration of it, and the trend is continuing strongly as well as we speak.
And so there's two parts to that, right? One is sort of general investor optimism. It's a good time to raise capital for things, and then the other part is specific about the way the economy is changing that improves returns specifically for these investments, right?
Yes. So the way the economy is, well, I would just say in terms of the capital that's going in, it's enabling companies to raise large sums of money, which again drives more innovation in what they're working. It's accelerating the pace of the technology, and also on the demand side, the demand for many of these digital technologies is also increasing, and the demand for understanding your data, the demand for the predictive analytics around your data as well.
So Amar, let's talk about your company. You're in the assembly space, if I understand that correctly. Can you talk about what Bright Machines does and how that business is impacted by the business changes that have been driven by COVID?
Sure. So we're an applied AI company. We're applying AI and machine learning specifically to the world of manufacturing. People understand autonomous cars. We build autonomous assembly lines. So these are assembly lines that are entirely manned by machines, robots, conveyors, feeding systems that are run by software to build products. And that has, the demand for that has, kind of building on what Stephen said, has dramatically accelerated because the pandemic has pointed out the reliance of humans in factories is something that our customers want to sort of move off of, and move that kind of repetitive task over to machines. And so we've been applying AI techniques using computer vision, using data synthetics, and all of those kinds of things to power these autonomous assembly lines, and it's been quite successful.
And how does AI change that? Because automated assembly is something that's been around for a long time. What is the artificial intelligence angle in that?
We called our company Bright Machines because we're literally trying to give eyes and brains to machines. The thing that humans are good at is handling flexibility and on-the-fly judgment, right? So you give me a set of pieces, I can figure out how to assemble them. Machines normally would have to be, literally hand configured, do this, then that, then this, then that, if this thing is not in this place. So today, these techniques that we get through modern AI and machine learning are adaptive. So from a vision perspective, it can recognize where a certain, let's say you're trying to put a screw in a hole, you don't have to tell it where the hole is. It can recognize where the hole is. It can figure out how much force to apply, just like a human would, like you jiggle. Those are the kinds of techniques now you can apply using machine learning and AI techniques that take over the work or substitute for the kind of thing that humans would have normally had to get involved in.
Sophia, obviously another area in which COVID has greatly changed both interest and investment is in health. Can you talk about what you're doing in that space, applying AI in a new way in health?
Happy to. I find it funny that three of the companies represented here are Bright and Spark. So that's the AI theme for you. At Brightseed, we're a data company, and we use AI to illuminate the connections that exist, but they're mostly hidden between plant molecules and human biology. And the reason we need AI is, first of all, to illuminate what science cannot see before this kind of approach. You would think we know everything there is to know about plants. They are all around us. They've been part of our supply chains. They've been the sources of medicines for centuries. And the truth is, we barely have scratched the surface. There are tens of millions of plant compounds, and science really only knows about 100,000 of them. And these compounds are super powerful for health. We were having a coffee right before coming here. This is the caffeine found in your beverages. These are the active compounds found in drugs, from aspirin to chemotherapy. And there is so much more to learn. So at Brightseed, we use AI first to understand what is in there. So plant compounds are prolific chemical producers. And with traditional machines or equipment or lab processes, it's a very linear and manual process to break the plant apart and then try to identify a single molecule that we need to understand at a structure level. At Brightseed, we scale that process. So we generate as much data as possible using really sophisticated equipment called mass specs. At Brightseed, we have the first in North America of this kind of capacity. And then we take that data and predict the chemical structures found inside of these plants. And with that visibility, then we can anticipate what these plants' molecules can do for health. And we train our models on that application as well.
And so, I mean, sort of much like automated manufacturing, this is an old thing, or part of it is an old thing. You know, we've used compounds in plants, as you know, and all sorts of things. So the way the AI changes this process is it was really basically like you'd sort of have to do trial and error, like maybe let's try this thing and this thing and this thing.
Pretty much.
And so what's the difference in productivity that comes from that?
Yeah, great question. So first of all, it's either trial and error or a random walk, where there is, to use like data science terms, there is a lot of noise but not a lot of signal. And so in the current pharmaceutical processes today, generate a lot of synthetic compounds, are put through high throughput screening equipment to test biologically whether these compounds can have an effect. But that is a lot of noise and very low signal, and the success rate of that is, 0.02% or in that order of magnitude. At Brightseed, our success rate is an order of magnitude higher, or a couple of order of magnitudes higher. We find that our hit rate is in the 2 to 3% rate, which is much, much higher than 0.02%. And also our success track record in both identifying the molecules and confirming that they are indeed the characteristics that we predict, and also in vitro validating our predictions is in really high, north of 90% success rates. So we've been able to take the guesswork out of it, and what we're finding as a bottom line is that we are surrounded by gold mines of natural bioactive compounds. We have now built the technology to be able to see them.
And so, Amir, these sorts of stories about huge promise from AI in a wide variety of industries, a lot of people who are in one business or another may be looking at this and saying, AI is increasingly relevant in my field. I have to figure out, is this something that I want to become a core competency for my business? Or is that something that can't really be a core competency for me? So I assume that, and this is, I gather, a space you're in, some people have to figure out, is this something that I bring in a partner, I bring in a technological solution to do this, or I try to do it in-house? How do people figure that out?
Yeah, I think first of all, the approach to artificial intelligence needs to be taken on at a very senior level. The reality is that you're driving a transformation, and when you drive a transformation in a large business, there is some, C-suite capital that has to be invested in it. But I think beyond that, if you look at kind of how artificial intelligence is changing these companies that aren't core software companies or aren't core AI companies. You look at companies that are producing pretty much anything. There's this ongoing pressure now, for the right reasons, to reduce the carbon footprint of the installed equipment that's out there. There's $100 trillion worth of physical infrastructure in the world: planes, trains, automobiles, pumps, offshore, oil rigs, pipelines, etc. So what are you going to do with them? Are you going to rip and replace them, or are you going to use some more intelligent mechanisms to prevent failure, to increase uptime, to reduce wastage, etc.? Those are problems of such gravity, and those are problems of such grave financial consequences that you can't simply rip and replace all that infrastructure. So AI becomes the only option. How that AI then applies to your business in your context, as a leader, you should understand. Do you need to understand the backpropagation algorithm and the difference between LSTMs and the latest neural architecture? Not really. But you should understand the value of artificial intelligence in presenting kind of a state shift. One very quick thing I'll add to this is that I hear a lot of misnomers nowadays. For example, artificial intelligence is just recognizing a pattern, or artificial intelligence is just statistics. And look, statistics is a part of artificial intelligence, but what we've done is we've taken the science of artificial intelligence, of which machine learning is an element, of which deep learning is an element, and deep learning uses correlational type activities which require a lot of data. And because a lot of the systems being built now are being built with deep learning, we abstract that back and we say all of AI is just all data dependent, and that's not true. So there is a lot of potential for things like one-shot learning, for genetic approaches, to evolve solutions in the absence of data, to create synthetic data to solve problems. And the reason I bring this up is because those are the types of techniques that for our customers are making the most difference. When we go and deploy on an oil rig or on a $100 million turbine or on a large pipeline, and if we were to turn around to the customer and say, give me 1,000 examples of your $100 million turbine blowing up, they would laugh us out of the room, right? There aren't any examples. Or if you go to the US Air Force and you say, we're on F-16, which we are, give us an example of, God forbid, 1,000 of them falling from the sky. There are none. So what do you do in areas, how do you apply AI in areas where data is incredibly sparse? And the answers to those questions are complex because there's entire areas of research which we are invested in. But my point is simply to say that there are more problems being solved and there are more problems solvable than a lot of the typical press that we've read about this has made the case, particularly for the C-suite. Because most C-suites that I speak to now are under the assumption if our data isn't all there, all clean, all connected, there's nothing for us to do. Not true.
Stephen, as you hear these stories across various industries, I think a question both for investors and for business executives is how promising is this specific application really? So how do you sort through that? What are you seeing as areas where the promise of this is really large and areas where maybe it's been overstated?
So just to go off of the back of what Amir is saying, we're kind of on the other side of the data spectrum, meaning like we like to see the data. We like to gather a lot of the data. So what we do at WorldCom Predictive is, we could actually build models, and I'll give CPG as an example, for a particular industry where we could go in and just using publicly available data, third-party data, we could build models around it and present it. Again, let's say it's around inventory management to a particular enterprise, and then the enterprise will say, well, okay, this is great, but like it's like, well, we say, if you actually add your data, your proprietary data into our models, the predictions become even that more precise. So, from our angle, like, and that's one of our differentiators is, we're data guys. Like, we literally start from the top, from the beginning of gathering, and there's an art form to gathering data, right? I mean, there's data everywhere. There's data created, massive amounts of data created every day, but to actually gather it, clean it, make sense of it, and then be able to fuse it with other alternative data sets is not trivial. And that's one of the things we're really good at. And on top of it, then we layer on our predictive models, and we have offices all over the world, which makes it, we have the leverage of of having diverse opinions when they build models around this data. And some of those advantages, give us more accurate predictions. But the industry is real. I mean, however you come at it, it's real. It's expanding. And for analog type companies that aren't adapting, they're going to get left behind.
I want to note, by the way, please, if you have questions, you can see the QR code that is visible to you somehow, right? Yes, right up here. So if you scan that QR code, you can then enter a question on your phone. It'll show up on my iPad right here. I want to ask Amar about the, as you're seeing, you describe processes that used to be,
Yeah.
that used to require a human because there was
Right.
so much judgment involved in them. Presumably that does a lot to change where you can deploy automation in manufacturing. And more broadly, across the economy, there have been some industries that over even centuries have had enormous productivity gains from automation.
Right.
Manufacturing, agriculture, and others that really haven't had that. Construction, not so
Right.
much. Anything involving the rendering of a lot of person-to-person service. Do you see this changing where those gains show up in the economy? Because that's been a driver of a lot of the big problems that we have about cost. A reason that healthcare and education got so expensive is that the productivity gains from automation, various things couldn't be applied there. Does this change? Do you see it changing where we can make those sorts of gains?
Yes and no. I mean, I think there's certain. Let me bridge the thing that Amir and
Yeah.
Stephen commented on. Like, I do see that at one level, AI is just a very practical technology. It's almost like somebody said this. It's like the new SQL database. Like, you really can start to use it in many situations and start to automate more and more things. And there's a lot of applications, tasks that can get automated this way. That's why RPA showed up and all those kinds of things. I think where you run into limitations is there are sometimes structures in industries. I spent a whole 30 years in the world of construction, and I think the barrier there is not so much technical, it's actually the way they allocate risk among the various participants, right? So you have the architect, the general contractor, the subcontractor, and as long as those structures and barriers exist, technology can permeate only to a certain extent. So I think something like AI has a huge amount of promise in taking away and repetitive, predictable, semi-predictable tasks, and helping also provide better decision support for things that are even not just predictable. So this has an enormous amount of potential. I think where it'll run into barriers is when you have some kind of structural issue in an industry that says, you can't automate across participants. And that's what I think in healthcare, happens in construction, because those industries are fundamentally about risk allocation and not so much about productivity. And that's where it falls apart. That's my personal experience.
Do the rest of you have thoughts on that? I think all of you have some contact with industries that might not ordinarily think of themselves as, early adopters for technology.
I was going to chime in with Steve's comment, but thanks for coming back to it. At Brightseed, we develop our own pipeline of bioactive products that we commercialize as nutritional applications. And we also allow and work with partners that use our technological platform. So we've become this infrastructure layer that can translate the bioactives that exist in plant sources and their potential health applications across multiple industries. So we work with number 1, 2, or 3 players in agriculture, in ingredients, in food and beverage, in nutritional supplements, and we're starting to work with players in pharma as well. Anywhere where you either have access and vested interest in that supply chain. Say I'm a large agricultural company. I want to decommoditize this grain or spice that I'm sitting on, and know why it's important for health and what about its chemical properties can be applied. Or I'm an innovative nutrition company and I want to find natural solutions for health concerns and not necessarily synthetic or artificial. So not every company, and what we find is that not every company needs to create their own AI. Our model is work with Brightseed, and we can enable your innovation pipeline as innovation partners. Leave the computational biology, data engineering, and data science to us. And we've had tremendous success with that model.
And I would agree with that. I think this notion of every company that's not a software company, that's not in the software business, now needs to become an AI company in the sense of building the tools and the platforms and the technologies, just not going to work. There aren't enough skilled AI people in the world that you could allocate across this broad range of companies and still have some talent that could make a difference at each one of these places. So I think the leverage of platforms built by AI specialists is crucial. It's just simply a numbers game. The other element that I would also say is that going back to your question, there are areas we've encountered. For example, Spark Cognition has done a lot of work in defense. And in that defense space, when you apply artificial intelligence, there are a lot of limitations. Data is classified. You can't really train on much of the data that would otherwise be easily trainable. Then there are ambits and there are mechanisms of control on systems. And in many ways, this is important not just because it creates an edge for the nation, but also because it is essentially the forebearer of the types of systems and checks that can be put into place that will apply to other industries. There's a lot of data governance challenges. There's a lot of auditability elements. There's a lot of even intent of the commander. In other words, is this AI actually doing what the person intended, and how will we validate that? So that's useful in a lot of regulated industries. And I feel that while today that is tough, it's not easy to just run an AI platform across everything in DoD. The tools that will come out of there will be broadly applicable even within the commercial space.
So, I mean, even if the data that is of interest to you is not classified, presumably one of the huge challenges here, especially when you're trying to partner with an outside company, is the data is very valuable. It says proprietary things about your business that are of interest to other people and not just to you. So how do you deal with that challenge if there are things that you really shouldn't be doing in-house? How do you deal with the fact that you might be giving away something of real value?
Well, there's a lot of challenges around working with proprietary data. Again, on the healthcare side, on the bank side, the KYC. There's a lot of rules around it, and each industry is a little different. That's why when we invest in companies, most of them, and it's hard. It's hard to build one general AI platform. They're out there, the big ones that are out there. But to actually get it right, you have to have a lot of vertical expertise, whether it be in manufacturing, in healthcare, or in chemicals. You have to have specific expertise around it. And in dealing with in dealing with that data, and the platform approach is amazing, and each platform will be different. There could be security issues on what data belongs to you, what data belongs to the platform. And there's a lot of governance questions around it. And we also look at data security companies as well, like who can interact with the data. But it really goes back to per industry and the data sets that you're working with. But on the platform approach, and that's where again, companies that are generally very promising, they have a platform in a particular industry, and also around the adjacent verticals where they're collecting data at scale. With people who are becoming their partners, and they have access to that data. Again, it's usually just anonymized in some form. Those become very powerful companies building off the platforms.
I think for us, it's the proof is in the pudding when we're talking about discoveries for health. And while all of our data is proprietary and we generate the data, so different than some of you up here is you could do AI on data that exists and that is public. In the case of Brightseed, we generate the data and have amassed that data set as a potential solution set to find answers. When we eventually go to market, these need to be biologically proven and scientifically proven. So the data for us is the starting point, and it enables a very focused approach instead of a random walk. And then there is the work of biological validation.
In addition to challenges of the value that your data might have to yourself, there's significant regulatory challenges here, and I understand regulation can be an irritation in this business, but there's also, I mean, there can be stakeholders outside your company, people whom the data concerns, who have an interest in safeguarding it, and then also that can create reputational issues for the industry. You don't want high-profile examples of essentially these things going haywire. So what do you when you look at the regulatory environment, what do you feel the government is doing right now that is hindering the growth of the industry, or is there a regulatory model that you see as working?
Well, I'll take that one. The Department of Commerce 2 years ago came out and asked for comments from industry, and we wrote a very long letter to them articulating our thoughts on where policy was kind of going awry. Part of this was around, for example, export controls. The export controls of artificial intelligence technology at the outset not necessarily productive, because the understanding of what is a critical element that needs to be protected versus everything else is not clear. So what ends up happening is that these broad brushes. Second is that in that discussion, we discovered that the regulators don't really have an understanding of how the stuff works, that there are layers. For example, there's data, and data can be proprietary. And by the way, there are laws today that disallow you from exporting proprietary data or national security related data. Then on top of that, you build a model. The model learns from the data, but it is not data, right? There's an IP ownership element to that. Then there's a platform that runs everything. Then there are data adapters that simply pull the data in your environment and clean it up and put it in the pool. So when you say AI systems banned, what does that do other than make our companies less competitive globally? And every time we've done that, there's somebody else that comes in and fills the void. So my view is that with regulation, the biggest danger I fear, and you saw this at Zuckerberg's, Senate hearings and basic concepts that were being thrown around back and forth, you could clearly tell that the folks looking to design the laws didn't know the basic concepts of what they were trying to control. This is happening in cryptocurrency. This is happening in many areas of fintech, which, by the way, is the #1 vertical now in terms of unicorn creation, 176 fintech unicorns. A lot of AI interplay there. You see this in autonomous systems. You see this all over the place. So that's the danger. People trying to control something they don't understand at all, and that has replayed now multiple times. So I think what we as an industry need to do, and as a group of investors interested in investing in technology, is to launch an education effort. The exact mechanics of that, of course, probably not the right forum to get into that, but this is an insurance policy to save US innovation. Because the worst threats that we now see are from people in positions of power that can regulate, that can control, that don't understand.
And so does then that look like proposing a narrower framework? If you're saying you're painting too broad a brush here, is there a way to identify, these are the things that really are appropriate targets for regulation, and these aren't?
If you would allow me, instead of using broad or narrow, I would like to use the word discernment.
Okay.
Discernment is really about an intelligent appraisal and understanding of the thing, and then an adaptation of what you want to impose based on you discerning what needs to be controlled versus what can not be controlled or doesn't need to be controlled. The discernment is lacking. In the wide and narrow, you could say, okay, here's one way to do it. All data is controlled. All models can go out. Platforms are okay. But if a government customer buys a platform, then you need to get special permission, right? Those aren't the right metric. They seem like you've segmented the space, but they're not the right segmentation. So they are narrower and broader, but they're not properly discerned as to what their nature is. And there's not too many people that I've been able to engage with that have those fine-grained understandings of these concepts. Without these, I think we'll end up with laws and regulations that are totally counterproductive.
Right. I would just add to Amir. Would you say that just because again, the people who are making the laws just really don't understand enough of what's going on. They just hear it from their kind of high-level advisors, some better advisors, but also their constituents are all jumping up and down on this, like socially saying like this is bad, this is bad. And then for them, they just kind of do a broad brush, and they want to look good in front of their constituents to kind of push the agenda forward. But it's become so broad that it affects things that it shouldn't affect. But I think really from the top, I mean, and you correct me if I'm wrong, it's the lawmakers really don't understand. There's so many dynamics going on, and you have a lot of lawmakers that just aren't in touch with the things that are happening today. Not that they could be, but
Yeah.
there's so much going on that and it's so broad, and the rules they make are so broad as well.
Well, I feel very strongly about that. So first, let me just say amen and hallelujah. I completely agree with what you're saying. But the second thing I'll tell you is that this is a societal danger, because what's happening is that there's a lot of criticism of technology. Technology promised us all these rewards and all this increase in quality of life, and where did that go, and why are wages declining, etc. I think the right use of technology hasn't been made. I don't think the government has made investments in the technology that matters to the people, and it's really around resource allocation. So look, you can, for example, you can invest a lot of money in hypersonics, right? We have now deployed the 2 first hypersonic systems with the U.S. Army, and it's a big program, and it's important, but that is not existing in a vacuum. That investment has 50 other things that you can consider before you decide to put money there. On one, you're going to get only a single dimensional return. On the others, you can get huge return. And I think you can give the dividends of technology back to the people. That's a planning issue. It's a resource allocation issue. I don't think it's being done well.
I think this is an interesting time for that, though, because wages are rising right now, and I think one of the other areas of public concern that has led to public policy concern about AI is the effect that it has on the labor market, and whether it's going to take away people's jobs. And I think one upside of this very odd economic situation we've seen over the last year is that we have this combination of businesses aggressively adopting new business practices that are more automated and more productive, and a tight labor market. It is a good time to go find a job right now. And so, Amar, I'm wondering, as these technologies get adopted more broadly, and maybe you want to talk specifically about manufacturing, what does that mean for the future of labor demand in these industries? Will there be fewer workers in these industries? What will they be doing? Will they be able to make more money?
Yeah, no, it's a great question, because while you guys were talking about regulation, I said my point of view is more on what's happening in jobs and reskilling. Yeah, I mean, there's probably 3 things I would say about that. One, you're exactly right about the fact that at the same time people are saying, we need to create jobs. There's 400,000 jobs in manufacturing today that are going unfilled, and that's because the level of technical expertise that is required is rising. So there are manufacturing jobs, and manufacturing jobs that are coming back from Asia and everywhere else, but they don't look like the manufacturing jobs of 20 years ago. They require higher level of expertise. And what's required is some level of investment in education and reskilling to take advantage of new technologies. And that's the one area that I feel the government in particular could be doing more, is preparing people to use these technologies. I mean, when we are saying machine learning, AI, how many, even at a very basic level, I'm not talking about somebody that can program a neural network, but someone that can use an application that's using a neural network at the bottom. There's just not enough skilled labor out there that we need to, between the industry and government, invest and create that. I think that's definitely something that it's important. And then, look, like every technology adoption cycle, there is displacement of workers, and there's retraining of workers, and then there's new job creation. You can look at the famous example with ATMs and banks. Like, those jobs don't go away. They become about something different. They emphasize interaction, they emphasize judgment, they emphasize innovation. And the thing that I believe that something like AI and machine learning is going to enable is that the more you can automate the routine tasks, the more innovation you can spur, the more creativity. And I know that sounds like some Silicon Valley nonsense that we have to say, but it's actually true. I mean, I look at the software industry. So I grew up in the software industry, and about 15, 20 years ago, there were like 50 software companies in the world that dominated, from Microsoft, Oracle, Adobe. And how many are there today? There's like 1 million of them. Seriously. Look at all the apps on your phone. They're all little software companies. What changed? The entire process of writing, creating, deploying software became immensely easier. And so what I look at that is, look at AI and ML in all the industries. Can it take over all the, like the, sorry, I don't think I could swear, all the nutty stuff that takes place in industries that consumes all this time and effort, and free up people to go after doing interesting things and then accelerate the rate of innovation, the rate of creation. And when we talk about labor markets and jobs, they're fundamentally getting redefined. You know, people talk about robots taking jobs. What I tell you is, walk into a factory. Every factory has robots. Unfortunately, most of the robots are human. There are people standing there doing the same task 10,000 times a day, in a factory, inserting the same component over and over again. They are robots, right? Now imagine that same task being done actually by a machine. What can we do with that human person? Can they go do something innovative, creative, contribute? So I do think we'll go through a 10, 15-year cycle of retraining. You'll have this weird demand versus supply disconnect, but if we can invest and retrain people, I think on the other side of it, you can really unlock a lot of innovation.
Sophia, what do you make of that?
I 100% agree. I think one of the barriers for our growth that slows us down is talent. If any of you have kids who are so inclined, computational biology or data engineering are really good fields. But in no way is Brightseed kind of getting rid of jobs, or the work that we do is getting rid of jobs. In the contrary, it's allowing for innovation in a whole new space that did not exist before. And I think, Amar, that is, I think when I think about manufacturing, then it's very clear for people. It's like, oh, there was a person and now there is a robot and that's AI, and what's going to happen to the person? So I think you have a tougher kind of communication challenge there. But I really underscore your point that AI is an enabling technology, and in the case, and we see it so clearly, we're able to see things in natural chemistry that science has never seen before. And the applications of that will be transforming. And we need a lot of talented people to make that happen. And that is in no way, shape, or form bad for the economy or for jobs.
And so conceivably, the job creation related to that, I mean, some of it is related to the new technology, but probably most of it is not directly related. Those new ventures, and it creates jobs that that certainly don't involve any expertise in artificial intelligence.
Yeah.
Might not even look, if you look at them, like they're related to artificial.
Exactly, 100% right. I mean, we're a small company today, and over 70% of Brightseed is R&D, and the majority of that is on the core technology side. And as we grow, so will grow the teams that need different kinds of skills. So I mentioned briefly, first is computational prediction, but then we need to biologically prove that the stuff that we find actually matters for health. And that requires biologists and clinical trials and a whole other kinds of professionals that are not involved in the AI per se, but that will also multiply in their demand as our kind of success grows too.
Amir, what do you see in companies using your platforms? How does that change how they use labor?
Well, I think, again, we deal with a large number of infrastructure companies. I think there are 2-3 categories of behavior that we see. One, in aviation as an example, today there are thousands of aircraft that are all manually flown, they're manually maintained, the routes are created manually, and so on and so forth. Everything is manual. And we're heading into a world where there will be millions of aircraft, all autonomous, managed autonomously, route development all autonomous, and they're all shapes and sizes, and they fulfill all kinds of missions. That is going to happen over the next few years. Now, that's not something that humans can do. So one is a class of activity that's a huge economic unlock that humans can simply not do. Another great example of that is in the cyberspace, right? So with cyber OT attacks, billions of assets all over the world, humans can't monitor them. So there's a whole category of things. It's not like I'm letting people go. They can't do the job. It's impossible for humans to do the job. That's one. The other is where you have augmentation, meaning that now one human can do the work of 10 humans from the past. And NLP technology, our deep NLP product, as an example, augments people so that if they know less about a technical topic, it can interject and tell them what to do. We combine this with augmented reality and really create an AR AI system that's a guided kind of a system. That's the second category. And the third category is where full autonomy yields an advantage. And the enterprise seeking that advantage just can't stay away from looking for that advantage. And there it's not about people, there it's about winning the outcome. McKinsey came out with a study a few years ago where they said that companies in various sectors that were first to adopt AI would create an insurmountable advantage. There's versions of that for the military side, NATO, DoD publications as well. So there are certain areas where when you apply AI in a very deep way, you create these self-fulfilling, self-refreshing, self-improving cycles. And if a competitor comes in 6 months, 2 years too late, they're never going to catch up. They're just never going to catch up. Your speed of innovation at that point, you're riding that exponential curve. So that will also start to manifest. So now the question is, business managers, resource allocators, investors, are they looking to optimize the number of people employed in those types of professions, or are they looking to optimize the best outcome given the purpose that that activity had? What do you do with everybody else? Retraining? Yes. But then look at all the other problems we have in this country. I mean, why aren't we spending on infrastructure? Why haven't we been spending on infrastructure for years? I mean, the Lord knows there's tons of things to do. So if the advent of automation to make one area more competitive means that there's a shift of labor, that shouldn't mean that that shift causes joblessness. It simply means that managed well under a decently thought through coherent policy, those resources can be allocated to things that we do need to do that are long overdue.
I want to put up the QR code again. If folks in the audience have questions, you can please go ahead and submit those through your phones. I want to ask Amar about, I mean, one reason that we haven't been investing as much in infrastructure as we might is that it is so expensive to build infrastructure in the United States. Partly that's a difference in global practices, but partly it's because some of these benefits that have accrued in other industries have not accrued there. I was wondering if you could talk a little more about your background in construction, what opportunities you might see there in terms of improvements in productivity that could arise from AI.
Okay.
Or are there not?
They definitely are. I mean, the construction industry, it's very labor centric. So, and it's also sort of, let me put it this way. One of the benefits of applying artificial intelligence is you become a data centric company. And you are able to shed light on things that you were not able to see before because you do put in practice either through physical sensors or getting data from other means, the ability to track a lot of the activity that takes place. And one of the fundamental challenges in construction has people have never really tracked things, reported things in a systematic way. And so, when somebody bids on, hey, it's going to cost $7 million to build this museum, they're bidding from their experience. It isn't actually like they have got every single piece of data and come up with a real conclusion that says it's going to take this long, it's going to cost this much, here are the 17 risks. One of the sort of the big opportunities in construction is, even before you get to AI, is simply by automating many, many work processes. And one of the biggest technological innovations in construction has been the arrival of this thing. Up until then, getting any kind of compute out at the job site, literally the edge, is impossible, right? You couldn't bring PCs to job sites. The advent of the mobile phone has really started getting the ability to capture, digitize information on construction sites and started to make a big difference there. The more data you collect, the more patterns you see, the more you can manage risks. And that's kind of where the whole productivity of the construction industry can start to change because you have visibility into what's going on where. I think long term, I'm very bullish on construction, whether it's for infrastructure or buildings, to really make a huge leap forward. but it all begins, and then you can certainly apply AI to make better decisions and better predictions, but it really is all about just basic level of automation to begin with.
Stephen, did you have a response on that?
On the on the construction side, I could see it's to me it just, and again, I'm no construction expert, but just on the analog side of things, and this is just from being in and around construction projects, residential and commercial, everything is fully analog, and there are companies that are trying to disrupt this a little bit, or at least help the businesses along. But I think it's one of those areas where, just because there's, and similar to other industries, there's a lot of resistance, from the incumbents that, they're afraid that in this case, construction, they may not be kind of like, automated out of a job, because obviously you need the construction. But in this case, there's just, everything is on paper. There's no digitization. There's no pattern recognition. So I think, and again, not being an expert in the construction industry, I mean, I feel like it's ripe, but it's also like getting a partner in the construction industry where you could actually build some data sets around publicly available data sets, and then getting their data and then maybe working on a few projects with them before you roll it out.
Go ahead.
I was just going to kind of underscore, Amir, you mentioned it first, and Amar, also in your world, the insurmountable advantage. And I think companies that know how to deploy artificial intelligence, that are doing so in ways that provide visibility in many different kind of examples that you've all set out, is it's not only a self-fulfilling cycle, but it's also an exponential curve, and that is a fantastic opportunity for anyone who is indeed along for the ride.
Mm-hmm. I want to look 25 years out. As I look as a consumer today, I can see applications of artificial intelligence in my life. I'm sure there are other applications that I'm not aware of that are causing the products and services that I receive to be better. But life doesn't feel that fundamentally different than it did 5 years ago, 15 years ago. Is there going to be an inflection point here? Is there going to be a place where we're going to say that that we're going to see either a huge overall increase in the rate of productivity growth, or some other point of change where we're going to say, this is really where we entered the AI era and it really changed our economy?
For sure. I mean, I think 25 years self-driving in specific environments, it's going to work out. I think that even more than that, I think aerial taxis. We have a session here at the conference later on, I think in an hour or two, with my friend Gary Geisen of Whisk is on that panel talking about flying aerial taxis. That's a real thing, and it's a few years away. And I think that changes cities. I also
We're going to have flying cars.
Flying cars.
That's a more fun panel later on.
Okay, I'll have to check that one out.
It's a fantastic panel, because if you aren't deep into the space, and when you hear these guys talk and they tell you about everything that's already been done, it's really, really fantastic. And in many ways, the problems you have to solve while you're flying are far simpler than the problems you have to solve when you're driving. So worth listening to. I won't make this about that panel, but that's another one. I think in the next 25 years, I think you're going to see a fundamental difference in how people approach money. I think technology-driven money, technology-driven trading, this kind of coming together of what's being built on the crypto side with conventional finance, this is going to happen in much less than 25 years. And it's going to change a lot. So, I mean, just these three things, and beyond that, of course, telehealth advancements. We'll probably have a lot. We've had 2 small autonomous conflicts in Libya and Nagorno-Karabakh between the Armenians and the Azerbaijanis. Over the next 10 years, I think there's going to be significant regional power, autonomous hyperwar-like conflicts. There's going to be multiple inflection points that will hit us over the next 2 decades.
Sophia, I assume that the idea with BrightSeed's technology is that there should be a lot of big changes in food and health, right? It seems like that could be a very big difference in the way that we're living.
Absolutely, and I think on a more optimistic note about the future, we think that in 25 years, with the technology that BrightSeed is bringing to across industries, we will be able to curb the incidence of chronic disease. disease that can be prevented, that we can be proactive about if we know what to ingest at a molecular level. And if we can make that available for people in any of the ways that they like to eat it or take it in a capsule or grow it or cook it. So that's indeed the trajectory that we see. With this kind of visibility that AI provides, fundamental societal shifts like the incidence of chronic disease, we will start to be able to curb.
Does that have to be limited to health also?
Great question. Our technology is widely applicable, and today Brightseed is very focused on health. But once you can see the molecular construction of these plant sources, you can do many things with that. We can talk about preservatives. We can talk about flavor. So it's not multiple applications beyond the ones that are specifically on human biology and health will also be possible.
So, Mar, we're gonna have flying cars. We're gonna have tastier, healthier food. Maybe
Yeah.
we're going to have really scary sci-fi automated wars.
Yeah.
What's on your 25-year outlook?
Yes, I have a simpler point of view. I mean, I'm a little terrified listening to Amir right now, but but he's probably right. So look, I think that the best technologies in the world are invisible. They become a part of the fabric, and I think that's going to happen with AI and machine learning. I mean, it's already happening when you talk to Alexa. It's already using pretty sophisticated techniques to go do this, and that's, I think, a model for the way AI and machine learning is going to roll out in a big way around in many things. It's just going to become more pervasive. I also think about the whole COVID vaccine thing we went through, this mRNA thing. I mean, yay, the vaccine showed up in a year. Which vaccine ever showed up in a year before this, right? I mean, and that's the kind of thing that I think over time, I'm hoping, the kinds of innovations that Sophia is talking about in her industry, what we're trying to do, like my Jetson moment for the world of manufacturing would be the equivalent of, hey, can you build this product for me? And the machines figure out how to build the product for you. It's not that far away. And change happens slowly and then suddenly. And we're watching that, right? You're watching this slowly building, and those moments where you're going to come up and these things are going to become just inherently simple, and you're going to take these kinds of interactions for granted. You said 25 years. I'm a little more optimistic. I think in the next 10 to 15 years, you're going to see many of these interactions you have become dramatically simpler because of AI ML becoming a part of the fabric.
Stephen?
So I'm gonna go a little radical, and I'm gonna say in 25 years, hopefully less, there's gonna be a quantum computing company that's going to be able to process all this wonderful data that's being collected exponentially. But one thing that we didn't address is, okay, we need the hardware to actually process this data. Like we don't have, with the end of Moore's law, what's going to happen, right? So again, hopefully sooner, but we're going to be able to glean information from quantum computers that we don't know we might not even know what we're looking for, and it's going to be able to answer questions because we could just feed it oceans of data. Of course, there's software involved in there as well, but I'll just stick on the 25-year outlook. There's going to be things that we're going to be able to solve with quantum computers that we don't even know what question to ask it today. But if that comes to fruition. Again, it's one of those things where it's not only a game changer, but it's a world changer in how we process, use data, AI, and ML.
So that's interesting because that's a vision that could be really exciting or really scary, depending on what it's doing, right?
If you're a crypto guy, you're probably a little scared. Yes, but if you're everyone else, you could be very excited. And, we actually have some software companies that, I'll say more on the experimental side of using it. But the results so far have been good. It's just basically in its early form, it's speeding up the processing. What would normally take a bunch of supercomputers months to process, you could process in 10 days or a week or a day, right? It's speeding up the process of all this data that's being collected exponentially.
Is there should we be concerned, though, about the computers getting smarter than us? I mean, because there's sort of, I mean, Amar mentioned the Jetsons, and George Jetson, I believe his work week is 3 hours a day, 2 days a week, and this is a very optimistic version of what it means that machines do everything for us. Or, I mean, or, you know, there's Blade Runner. So, like, what's, you know, if that comes to pass, and if there's this tremendous power and the computers are finding answers to questions we don't even know we had, that seems like it could go in very unpredictable directions. How do we ensure that it goes in a direction that we like?
There's really no way to ensure it. You always have, like,
Well, that seems like a problem.
Yeah, like there's really no way. I mean, no. I mean, you always have bad actors. Hopefully, you don't have a bad actor that, that gets a hold of it and hacking, and for hacking reasons. But, as on the good use of it, like it's, it really has to be programmed by a human in one shape or form. Like if it goes off on its own, like that, I don't know. Like that's a little too far out there for me. So
No, but just to make you feel better about quantum computers.
Okay.
Quantum computers can't solve any problem. Quantum computers solve very specific types of problems. They're not a general purpose computer.
Yep.
Secondly, the cryptography element of whether it's crypto or any other kinds of security, the big fear was quantum computers would arrive and all security would die. Not the case. There are quantum safe cryptology algorithms now, and in fact most of the major blockchains, they are migrating to that technology in the right period of time. Obviously the intelligence agencies have figured that out. But the biggest value of quantum computers is going to be life sciences and material sciences, where the current simulations on material science are so slow at high fidelity that with conventional computers, you can't really predict where the whole thing is going. So quantum computers are essentially not just computers, but they're doing the thing that they're simulating, at a particle level. So they're the best simulators for problems like that. And that is all goodness. Now, you can say, well, that might be some super soldier material, or it might be some great medical discovery, or it might be some amazing discovery that allows us to build a space elevator, right? All those things are possible. But the most near-term potential for quantum is going to be in material sciences. And quantum computing is today very, very limited, not just from a hardware standpoint, but from a software standpoint. You cannot do everything you can do on a general purpose computer on a quantum computer.
And that is all the time we have. I want to thank all of you for a very interesting conversation.
Thank you so much.
All right, thanks.
We hope you enjoyed the discussion. Please make your way to the next session.